Chapter 3.2, Polynomial Functions of Higher Degree. So let's say what's a polynomial? Okay, let's say p of x is a polynomial. Then the polynomial has degree, something like this. a1, x to the nth power. So, n is the degree of a variable x, input variable x, plus, another one, let's say, n minus 1, and a3 times x to the n minus 2, and so on. And going all the way up to, variable x plus, and then some constant. Right? So this will be some kind of, a to the, n? Something like this. All right. Then, for example, the polynomial. So, for example, like this. Polynomial can be a constant. This means the degree is 0. This means the degree is 0. And then p of x equals like a linear equation. 3x plus 1. Then what's the degree? Then the degree will be 1 because the exponent of the variable x is 1, right? And then quadratic function, something like 4x squared plus 3. Then the degree of the polynomial is what? 2, right? 2 because the exponent is 2. And then polynomial p of x is 2x to the third power, and then we may have x term, or we may have x squared term. It doesn't matter. Then this is, what's the degree? The degree is 3. So we say the degree of polynomial, that means it's the degree of the highest term. So if the highest term, if a term has the largest exponent, then that is the degree of the polynomial. All right. And then we call leading coefficient. So the coefficient of the highest degree term. Okay, this is the highest degree term. Then we call this the leading coefficient. Leading coefficient. And this leading coefficient is really important because using this leading coefficient, we can see, we can determine the type of graph. So for example, if the leading coefficient, let's say a1, okay, a1, let's say a1 is the leading coefficient, then if a1 is greater than 0, let's check the graph. The graph of all these types. The graph of constant function is what? The graph is horizontal line, horizontal. So this is y equals 2. P of x equals 2. Horizontal. This is linear. Right, linear. And this, the next one is if the degree is, the linear is when the degree is 1. This is constant, right? Constant. And if the degree of a polynomial is 1, then this is a linear. Linear. So it can be a straight line, straight line, something like this, straight line, right? Okay, and then if this is a quadratic, then the graph is concave up or concave down, right? For the linear, so the right end may go up or the right end may go down, right? That's the linear. All right, and then the cubic function, then the graph looks like this. Like this. Or if the right end goes down, then it looks like this. Okay. So as the degree increases, it looks like this. Okay, let's say this is x-axis. And if the leading coefficient is positive, then always, if the leading coefficient is positive, always the right end, far right, we call it far right, the right end is up, towards up. So if this nth degree is 1, 2, 3, 4, 5. Look at this. Can you see the intersections? So 1, 2, 3, 4, 5. If there are 5 intersections, then it may be the degree may be a 5. So if the degree, so if polynomials, the degrees, let's say a1 times x to the 5th power plus something, then we know the degree is 5. So at most the graph touches the the x-axis 5 times at most. Okay, and then since a1 is greater than 0, the right end goes up. Okay, so if a1 is greater than 0, the far right, we can say far right, the direction of the far right is upward. Far right is to upward. Okay, the far right is to the upward. All right. How about if a is less than 0, negative number? Okay, let's say polynomial. Okay, let's say this time, okay, same thing. a1 times x to the 5th power plus blah blah blah. We don't know. Then since if a1, the leading coefficient is negative, then what? Then the far right end is towards what? Towards to the downward, downward. So the direction will be downward. So it looks like this: 1, 2, 3, 4, 5. Can you see it? So at most, so the degree 5 has at most 5 intersections, x-intercept. All right. So it's really important. The leading coefficient, the sign of the leading coefficient. If the sign of the leading coefficient is up and positive, then the right end goes up. If the leading coefficient is negative, then the right end goes down. Okay. All right. So if the leading coefficient is positive, then the right end of the graph is upward. And if the leading coefficient negative, make sure the right end of the graph is downward. Okay, there's another very important concept is the degree. If the degree is even, then both ends, the right end and the left end of the graph is the same direction. Okay, the direction of both ends are the same. If the degree is odd, then the direction of the right end and the left hand is opposite direction. So one is up, then the other one is going down. Okay, so let's check this one. So as you see this, linear, right? Linear. If the quotient, so the slope, right? Actually the slope, isn't it? The slope. The A1 is positive, then the right end is up, right? If the slope is negative, that means the leading coefficient negative, then the right end goes down. Okay, for quadratic, same thing. And then the degree, let's look at the degree. If the degree is 1, that means linear. So look at the direction of both ends. The direction of the right end is going down, the direction of the left hand is going up, right? So the direction is different. But as you see in quadratic, if it's a quadratic, then the graph looks like this. Either if the right hand is up, then the left hand is also up. If the right end of the graph is down, then the left hand is also down. So always the direction of both ends are the same if the degree is even. Okay, even. So as you see this 5, x to the 5th power, right? 5th power. The right end is up, right? 5 is odd number, odd. And then as you see, the left hand is going down, right? So the direction of each end is different, in opposite direction. All right, so keep in mind these two important information. Okay, now let's check the far right and the far left behavior of the graph of each function. All right, the first one is x cubed minus x. Then what's the leading coefficient? The leading coefficient is 1, which is greater than 0, right? So we know that the right end goes up, right? Right end goes up. And what's the degree? The degree is 3, so that is odd. So different direction. Can you see it? Different direction. So we may have something like this, different direction. So since the leading coefficient is positive, the right end goes up. And since the degree is odd, the left end is going down, right? So far right is up, far left is down, because different directions. Okay, how about letter B? So what is the leading coefficient? The leading coefficient is 1 over 2, right? That's greater than 0. So right end goes up. The right end goes up. And then what's the degree? The degree is even, right? Even. So same direction, right? Same direction. Same direction. So if you graph it, something like this. Something like this, right? So right end is up, and the left hand is same direction as the right end. So that's up. So both far right and far down and far left is both are what? Upward. Right? Upward. Okay, the next one. Okay, negative 2 is the leading coefficient, right? So that's less than 0. So right end is going down. Right end is down. And the degree is 3. Degree is 3, so which is odd, right? Odd. That means different direction. Right? Different direction. In opposite direction, right? Opposite direction to the right end. So the graph looks like this. Right end is down, so you can go like this. So the graph looks like this. So the far right is down, and the far left is what? Upward. Okay, the last one. Okay, we need to rewrite it so that write in descending order by the degree. All right, then what is the leading coefficient? Leading coefficient is negative 1, right? Negative 1. So leading coefficient is negative 1. That is less than 0. So the right end should go down, right? How about the degree? The degree is even. Same direction, right? Same direction. So it looks like this. The right end is going down. So 1, 2, 3, 4, same direction. So it looks like something like this. The graph looks something like this. So right end is down, and the left end, so far left, is also down. Okay, can you see it? Okay, so this is really important. Okay, check the leading coefficient, whether it's positive or left, positive or negative, and also check the degree, whether the degree is even or odd. Okay, now the definition of relative minimum and the relative maximum. Okay, that means, okay, before we do this, there is an absolute maximum and absolute minimum. Okay, absolute means no matter what the value is, for the range, the y values, the range is the y value. So the minimum range, the minimum value of the range is, we call it absolute minimum. So in this case, the lowest point is this one, right? The lowest point is this. So we call this absolute minimum. Because at this point, all the y values is greater than this point. So this is the lowest, this point has the lowest y value. So we call it absolute minimum. But in this case, there's no absolute maximum because the right end is going all the way up and left is also going all the way up, right? So there's no absolute maximum, but this one has absolute minimum. How about the turning point? We call it a vertex. So at this point, here's the turning point, here's a turning point. Each turning point has maximum or minimum, around that graph, right? So we call this turning point. If this is the lowest one, lowest point, around this point, then we call it relative minimum or local minimum. So locally, this is the minimum y value. This point has the minimum y value, locally, right? Local. So this is called the local minimum or relative minimum. So we'll use relative minimum. Relative minimum. Okay, so relatively, this point has, relatively the lowest y value around this point. How about this one? Then we call this relative maximum. Relative maximum. And so on. And this point is what? Relative minimum. All right. And then even still the same thing, still same. So relative minimum, relative maximum are the local maximum or local minimum. And absolute is what? The lowest y value. It's the point that has the lowest y value is called absolute minimum. And absolute maximum is the largest, the highest, the greatest y value in the graph. Okay, the next question is, here is a rectangular board which is 16 inches length and 12 inches length. And then we're going to cut in the corner, so the size will be x. So we will cut x inches, on each side, each corner. Each corner. All right, then we can make a the open box, right? We can make an open box using this one. So we will cut off the corners, right? Cut off the corners. Then we can make a box like this. All right? It looks like this. Right? And then this is actually since x is removed, x inches removed from each corner, then this length will be 16 minus, okay, let me rewrite it. So this distance, the length is 16 inches, right? So then this distance will be 16 minus 2x. So the length of the box will be 16 minus 2x, and the height is x, right? Because, we cut, x inches from the corner, and this will be same. So this is 12. So this will be 12 minus 2x, right? 12 minus 2x. So we can make a box, open box like this. Open box like this. So from here, okay, let's find the volume of the box. Let's write an expression for the volume of this open box, and then we will determine the maximum size of the volume. So that we can. We will need to find the length x. We need to find x so that we can make the volume of the box maximum. Okay, that's what we're gonna do. All right, I redrew the diagram, and then the volume, the expression of the volume is the product of length, width, and height. So we can rewrite it. The length is 16 minus 2x. The width is 12 minus 2x, and the height is x, right? So that's the volume. Then, you can rewrite it. So you can rewrite it, use the distribution. And then if you rewrite it, then maybe it looks something like this. 4x cubed minus 56x squared plus 192x. But this is not necessary. This is enough. All right, then letter B. We want to find x. Okay, find x so that the volume will be maximum. All right, then let's use the first one. This equation, the first equation. So from the equation 1, the volume x is equal to what? Rewrite it. Let me rewrite it. So x times 16 minus 2x, 12 minus 2x, right? So the graph. Let's check the graph. Let's check the graph. How it look like. The leading coefficient. What's the leading coefficient? The leading coefficient is what? The leading coefficient, which is 4, is greater than 0. So the right end is up, right? And the degree. What's the degree? The degree is odd. So different direction. the opposite direction, right? Opposite direction. All right. So since there, okay, let's find the x-intercept. Now, to find the x-intercept, we set each factor 0, right? 0. X-intercept. Okay, let's find the x-intercept. That means x equals 0. X equals, so let's make the second factor binomial to be 0. Then x equals 8. The third one is x equals 6, right? So here's a 0, 6, and 8. And the graph looks like this. Something like this, right? So from here, we want to maximize the volume, right? Volume. So maximize the volume, that means we need the highest point. Since x is the length, x is the length, x cannot be more than half of the width. The width is 12 inches, right? Width is 12 inches, so half the width is 6 inches, right? So it cannot be, x cannot be in this range. So x has to be between 0 and 6, right? Between 0 and 6. So we have to find this value. This is the x that makes the maximum, right? Maximum. So in this case, we gotta use a calculator to find this point, to find x at this point. So unfortunately, you gotta use calculator, otherwise we have to use derivative. So use a calculator and then graph it. Use a graphing calculator. To sketch the graph, and then find x where find the x of the local maximum. Okay, find x value of the local maximum. Can you see it? All right. Then x will be, is approximately 2.26, 2.2629 something. So x will be x is approximately gotta be 2.3 inches, right? Inches. So that's the solution. All right. Can you see how we find the maximum volume? So even we have to use the calculator. In the calculator, we gotta know how to use it, right? We gotta how to use it, how to see the graph. So the graph looks like this. The right end is up, and then there are 3 x intersection, right? And x cannot be greater than 6 because the width is 12, and half the 12 is the x, right? At most. So by looking at this, we find the local maximum. So the local maximum will give you the maximum value. Okay, now next definition is intermediate value theorem. Intermediate value theorem is, it looks complicated, but it's really simple. So let me draw a graph. Here's x-axis and y-axis. Let's say there is a graph, something like this. Here's a graph, and then get the x value. Here's at A and B. Obviously in this case A is less than B. Okay, A is less than B. Then there is a point, right? P of A, right? This is P of A, and this is P of B, right? P of B. So if the domain, if there are 2 x values, and if A is less than B, then the y values of A and B are different. I mean, the y values of when x equals A and B, they are different. Okay, so this is the condition. So 2 y values are different. Then, there is a point C. There's a point C between A and B, right? There's between A and B, so that such that what? The P of X, P of C, right? So P of C is equal to, is between what? Between these 2 values, between these two y values. This is P of B, right? P of B, this is P of A. So P of C should be between these two y values. So for example, in this case, if C is x-intercept, right? C is x-intercept, right? So if P of C is 0, then that C value will be the x-intercept. Can you see it? So there are two y values, and they are not the same. Then between these two y values, so y value can be a 0, right? Because one is positive. In this case, P of B is positive. This is positive, right? Positive. And this is negative. So between positive and negative, then there is 0, right? 0. So y can be a 0. There's a y value which is 0. So that there should be a value, x value C, so that the y is 0. Can you see it? Alright, so in this case, P of B is positive. Sorry, P of B is what? Positive, right? Positive. And then P of A is what? Negative, right? Negative. So there is P of C, so that the P value is 0. The y value is 0. Does it make sense? Okay, let me explain again. Similar example. Let's say in this case, it looks like this. Let's say it looks like this. All right, let's say this is A and this is B. Then A has this point. So this will be P of A, right? P of A. P of A. And this point is P of B. So the y value is P of B. So in this case, P of A is what? P of A is positive, right? Positive. And P of B is negative. So there is a y value C, so that the y value is equal to 0, because one is positive, one is negative. So there is, between this y value, this is 0, that's 0. So there is a point C, so that the y will be 0. Can you see it? So this point, right? These points. This is C. So in that case, so this is called intermediate value theorem. Very simple. Okay, A is less than B, and then the y values of A and B are different. Then there is a y value between these two y values, and then since there is a y value, there is a C value between the x interval A and B. All right, that's our intermediate value theorem. All right, now verify that this function P of x has a real 0 between 1 and 2. So if x is between 1 and 2, that means there is a real 0. The real 0 means the y-intercept. X-intercept, right? X-intercept. So this means here is, I don't know how the graph look like, but here is -1, x is +1, and x equals 2. So let's find out, using the intermediate value theorem, let's find out the P of 1. Okay, P of 1. And if they are different, then if P of 1 and P of 2 has different sign, then there is P of C that is equal to 0, right? So let's plug in P of 1. So 1 cubed minus 1 minus 2 equals -2. So this is less than 0. Right, now P of 1 is less than 0, -2, and P of 2 is what? Probably this one is positive, so let's plug it in. So 2 cubed minus 2 minus 2 is 8 minus 4 is 4. That is greater than 0. So when x equals 2, then y is 4, right? 4. So this is P of 2, and this is P of 1. So P of 1 is less than 0. So I don't know how the graph look like. I don't know how the graph look like. But as you see this, when x equals 2 is positive, when x equals 1 is negative. So there is x-intercept, right? There's an x-intercept. So the P of C will be what? 0, right? 0. The y value is 0. So since this one satisfies the intermediate value theorem, right? Okay, so P of 1 and P of 2 have what? Opposite signs, different signs. So there is, P of C, that is 0. So there is a point C. This is the real 0. This is the real 0. So this is the real 0. So we just proved. So actually, C can there can be at least one, or at least one, or there may be a more, because here's x equals 1, x equals 2. Then it can be something like this. We never know, right? We never know. But in this case, x cubed. So this is not realistic. It can be or something like this, right? Something like this, and this may be 1, or this may be 2. Then in that case, there are 3 x-intercept, but at least. Anyway, there is a point C, so that the y value equals 0. All right, and then we already, I think I already mentioned this one in earlier chapter sections. Okay, the following 4 means the same. So for example, x minus c is a binomial, and this is a factor of p of x. So let's say p of x, something like this. Let's say p of x equals something, and then if this one looks like this, x minus 2, x plus 2, and then x minus 1. Just an example. Let's say p of x is x plus 3, x minus 3, like this. Okay. Then we know that x plus 2. Each one of these three binomials are what? Factors, right? Factor of p of x. So if this is a factor, that means x equals c. So when x equals -1, then -1, we can set each factor equal to 0, right? -2. We can set each factor equal to 0, right? Then the graph, something like that. The graph looks like this. Because this is a cubic function, and then the leading coefficient positive, so right end is up. And then since this is an odd function, the other side goes down, right? So as you see this, each point on the x-axis is what? The real zeros are real zeros. Real zeros means, you let p of x equal to 0, then find x, right? So for each point, this point means, x minus 3, right? X minus 3 is a factor. This means x minus 1 is a factor. And then this point is what? X plus 2 is a factor. So multiplying all these three will make a polynomial. And then when x equals -2, x equals +1, and x equals +3, then this will make the polynomial 0, right? Make the polynomial 0, so that we call it real solutions, right? Real solutions. Also, we call it real 0. So since this makes the y value 0, they are called what? X-intercept, right? They are all x-intercepts. Right? They are called x-intercepts. Right? All right, so all these 4 meaning the same. Okay, keep in mind this one. And then let's check the powers, odd power and even power theorem. All right, so next one is really, really important when you sketch a graph of polynomial. Very useful. So, sometimes, the binomial has nth power. Sometimes it can be odd power or even power. So, if the power is odd, so in this case, x minus 1 means the exponent is 1, right? Then the x-intercept, then the graph crosses the x-intercept. Very simple, just cross it. If the power is even, like this one, 2, then the graph does not cross the x-axis. It touches that point, x-intercept, and bounce. Okay? So let's try this. In this case, the x-intercepts are 1 and -1 and -2, right? These are the x-intercept, So let's check. And the leading coefficient is 1, right? That's positive. So right end is up. And we know that the degree is, once you multiply everything, then the degree will be x cubed times x squared times x. So it will be x to the 6th power, right? Degree is even, right? Degree is even. So it will have the same direction, right? Same direction. All right, so keep in mind this one. And then when we apply this, odd power and the even power, then it will make this, the graph will be same as what we had like this. All right. So when x equals 1, the degree is 1, right? So we know the right end is up, right end is up, right? Right end is up. So from this, let's go down. And then when it touches here, it goes what? Cross the x-axis. Okay, cross the x-axis. And then when x equals -1, the degree is even, right? The degree is even. So we will bounce at -1. So going down and then change the direction and then go towards -1, right? And then we bounce it like this. All right. And then when the degree is 3, when x equals -2, then the degree is odd, right? Odd, then cross the x-axis, right? Okay, this one is odd, right? So we cross the x-axis, right? So when x equals -2, okay, we will cross this point. So turn the point, so this turning point, and then go all the way up, right? Cross it. So the graph looks like this. So as you see this, the degree of the polynomial is 6, which is even. So the right end and the left end should be the same, right? The far right and the far left will be the same direction. Yeah, it makes sense, right? It makes sense. So this is a very useful theorem, odd and even power of binomial. In any factor, not even binomials, it can be just monomials defined. All right, so it's very useful. All right, so the procedure, the steps for graphing a polynomial function is, let's summarize it. So let's say p of x is a polynomial, an x to the nth power, an minus 1 x to the n minus 1 power. All right, so an is the leading coefficient, right? This is the leading coefficient. And then we know that, an cannot be a 0, so leading coefficient. All right, so the first thing is we will check whether the leading coefficient is positive or negative. So if the leading coefficient is positive, then the right end is what? Right end is up, right? Upwards. Okay, right end. We call it far right, right? Far right. Far right is upward. If an, the leading coefficient is negative, then the far left is downward, right? I'm sorry, far right, sorry. Far right is downward. Same thing, far right is downward. Always the right end, okay, check the right end. And then, and also it's easy to find the y-intercept because you just set x equals to 0, then find y value. So find the y-intercept. And then also find the x-intercept. So this is the tough one. X-intercept, we have to factor the polynomial. So set the polynomial equal to 0, and then, do the factoring, right? Factoring so that we can find all x-intercepts. All right, and then once you factor everything, then check the degree of each factor. So if the degree is odd, just like this in the above example, if odd, then cross the x-axis at that x-intercept, and if n is even, then touch the x-intercept and bounce the x-axis. Okay, so this is the main concept. Okay, main concept. All right. There's another one. Also check. Okay, number 5. If the degree of of polynomial, right? Polynomial is odd. Then what? The far left and the far right has different what? Different direction, right? Always keep in mind this one. So far left and far right, the direction of the left and the right end is opposite. They're different direction. And if this is even, then the direction of are the same, right? They are the same. Make sense? So number 5 is just for your reference. So if your graph is correct, then the number 5 must be satisfied. So let's try this graph. Okay, P of x. Okay, I rephrased the number 5. Okay, let's graph exercise number 6. Okay, first, what is the coefficient? Let's check the coefficient. Okay, 1. The coefficient, coefficient is 1, right? That is greater than 0. So the far right is up, right? Is up. So it looks like this, right? Okay, how about the degree? The degree is 3, which is odd, right? Odd. So different direction. So the right hand is up and the left hand is what? Down, something like this, right? Okay, and then let's factor, what's the y-intercept? Okay, y-intercept is really simple. Y-intercept is set x equals 0. Let's set x equals 0, then p of 0 is equal to what? 0, 0, 0 is 0, right? 0. Okay, so it looks like 0. Since the y-intercept is 0, then also 0 is the x-intercept. Let's find 4. The number is different from the above. Okay, let's find x-intercepts. So I'm going to set p of x is equal to 0. So that means x cubed minus 4x squared plus 4. This is tough one. So we need to factor this trinomial. Okay, there is a common factor x. So factor out x. Then x squared minus 4x plus 4 equals 0. This trinomial, we can factor it. So x times x, 2 times 2, both negative, will make the sum of the cross multiply is negative 4x, right? So we got the second term. So if we rewrite it, then it will be x times x minus 2 times x minus 2 is equal to 0. So p of x, so in this case, x-intercepts are what? Set each factor equal to 0. So x-intercepts are x equals 0, x equals 2, and here's another 2, right? 2. So if you rewrite it, then this is x minus 2 has 2. The binomials are the same, so it's a square. So if we rewrite it, then p of x can be written as x times x minus 2 squared. All right? All right, so we found everything. So here it is x-axis and y-axis. Let me draw this one on the right side. X-axis, y-axis, and the x-intercepts are 0. Here's a 0. Here it is 1 and 2. Okay, let me just use 2. All right, so here's x-intercept. There are 2 x-intercepts. And the graph, look at the graph. The right end is up, right? The right end is up. And then the y-intercept, what's the y-intercept? Is 0, same thing as this one. Okay. And then look at this one. This is even, right? Even. So what? Bounce, right? Bounce the x-axis. Bounce the x-axis. Right? And this is 1, right? 1. That means what? Cross the x-axis. So at this point we will bounce it, and then when crossing, when it comes to 0, then we will cross this x-axis. Okay, the right end is up, right end is up, so it's gonna be something like this, right? So let's go the other direction, and when x equals 2, we will bounce it, so going down to 2 and then bounce, right, bounce, and then change the direction. When it comes to 0, then what? Cross, right? Cross. Okay, let me try it again. So from here, okay, so right end is up, right end is up. Then this will make going up, right? And then at x equals 2, bounce. Bounce it. And then change the turning point. I'm not drawing well. So bounce it and change the direction, right? And then cross this point. All right. So right end. So look at since the degree is 3, which is odd, the direction is different, right? The right hand, the left hand are different. Okay. All right, the last example is, model an application with a cubic function. So this means, data is given. So actually we don't know the polynomial. So using the data, we got to use a calculator. So we will skip this part because, you have to enter all this data in x values, y values, and then let the calculator find the polynomial function with the degree 3, cubic function. So using a calculator, you will generate a polynomial function so that we can, use those functions to estimate something. So let's skip this part. All right, so this is the end of this section.